So my name is Marcin, Czech, and today, together with Chris, we would like to talk about the work which was recently done for processing multiple refs updates as a single ref event. I'm going to cover the Gerrit core part, and Chris is going to talk about the changes in pull replication. So actually, Gerrit can handle batch ref updates thanks to amazing work done by Thomas Drabing, but there are some limitations. First, to listen to those events, you have to implement a Git batch ref update listener. This means that you cannot use the standard event listener way to listen to the event bus and internal Gerrit event bus and get those events. Another limitation is that batch ref updates are not part of Gerrit stream events. This means that you cannot listen on them from the external systems. And the last one is that the ref's order is not preserved. Based on that, we decided to do a few improvements. First is to actually preserve ref orders. It's quite important because let's imagine that you are creating a change. So when you're creating a change in Gerrit, Gerrit is going to create two refs. First is a patch set ref, and the second is a meta ref. And Gerrit batch update has always the proper order. So first is writing the patch set, and then is writing the meta ref. But because of the how the Git batch ref update event was implemented, it can be we can end up in the situation that this order is mixed in the event itself. So when you're listening to those events, there is a chance that first you're going to process the meta ref and then the patch set, so your change can be in an inconsistent state for some time. That's why we changed that code. So now we guarantee that the order is going to be exactly the same as in batch update. The next improvement was to create the batch ref updated event and stream it via stream event bus. So this is how the new event looks like. So on the top, you have the ref updated, which is the old way. So as you can see, when you're creating a change, you are getting two separate events, and you don't have a context. They belong to the same update, and and basically it's more noisy as well. So in the new event, batch ref updated, everything is coming as a single event. So you can so all the let's say you have the logical unit, which is which contains two refs, and you can react on those in a smarter way. So for example, if processing one of the ref is gonna fail, you can roll back the whole batch ref update, so we're gonna roll back the full logical unit. How to enable the batch ref update events? So basically, we introduced two new Gerrit configurations. First is enable batch ref update events. By default, it's set to false. Second is enable ref updated events. By default, to true. We did that because we want to keep the backward compatibility. We know that there is a lot of integrations listening on stream events, so we want to make sure that we're not going to break any existing code. So by default, batch ref updates are not streamed. So we are recommending you to go to your testing environment, enable them, check if your integration works as supposed to, and maybe modify the code to handle the batch ref update event, and then you can move it to production. One important thing, when you are enabling the batch ref update events, you should disable ref update that events. Because if you're gonna keep both to true, you're gonna get duplicate events. Basically, we're gonna generate both. This code is available on master branch, so please feel free to start. Thank you. I'm going to hand over to Chris.
I'm Chris. I'm a software engineer. Originally, I come from Greece. And for the last too many years, I have been living in London with my wife and my two daughters. So Marcin has already covered the Gerrit core changes. I'm going to be talking about the pull replication use case. We're going to cover the two different parts of the solution, the batch apply object and the batch fetch. We're going to do a short demo, and then we will take questions. So what are we trying to solve here? What is the problem? The problem is we want to basically minimize the pull replication latency that occurs from a single user action which updates multiple refs, for example, a push. And generally speaking, the concept of batching, it's not present in pull replication in the sense that essentially every ref is processed individually. And what that means, this is a little bit suboptimal, because if you have an action that updates multiple refs, then basically what's going to happen is you're going to have one request per reference. And as Marcin previously mentioned, this can also lead into an inconsistent state. For example, if you got first the meta ref and that was replicated correctly, but then you fail to replicate the patch set ref, then this can cause problems. So the question here is, what if we could get all of the updates and send them to the replication target in one single call? And this is what we have been working on lately. Most of the work is done, so most of the code is available in the master branch of pull replication. However, there are a couple of bits that are still work in progress, which I'm going to cover later in the presentation. Before I dive into the solution, let me give you a little bit of a background for those who don't know a lot about pull replication. So the changes span over two different axes, the apply object operations and the fetch API operations. Now, the apply object, a typical apply object request contains not only the ref names, but the revision data of the ref in the message payload. So this includes, the commit hash, the tree, the blobs. So all the recipient has to do on their side is just apply those, parse the payload and apply those locally. So compared to the fetch API operations, this is much faster. The fetch operations are essentially a fallback mechanism in pull replication. So we will fall back to the fetch API if the apply object request fail, if that call fails, or if the payload is too large. And the difference here is that the request to the fetch API, the payload itself contains just a list of the refs, so the ref names, nothing else. So when the recipient gets that message, they need to schedule a git fetch based on the list of refs that they have. And obviously, this is going to be slower compared to having all the data already in place and apply them locally. Okay, so the first part of the solution is around the apply object endpoint. Obviously, a prerequisite here is the batch ref updated events to be enabled, which is what Marcin talked about earlier. We have introduced a new endpoint here called batch apply object. And here I have an example of the payload. This is from the pull replication logs. And we can see that first of all, we are calling the batch apply object the REST API, but also we can see the payload itself, that it contains a list of the refs themselves. So we have in here we have the patch ref and the meta ref with the revision data. So you see the commit object hash, the tree object, the blobs, etc. So essentially what we're doing here is we are preserving the refs in the batch as they came, but we do a small enrichment, adding the revision data, and then we package the whole thing into one single request and send it over. Now, this behavior is disabled by default, and it can be enabled by configuration in the pull replication config. The setting is called enabled batch refs, and it's under the remote namespace. there are a couple of things worth mentioning here. The first one is that the behavior is enabled, as you can see in here, per remote target. And this is because you may have different instances that are running different versions of Gerrit. So if we were to, assume that all of them, if we were to blanket enable this regardless of the replication target, then if they're running different versions of especially of the plugin, then we might be getting 404s or different sort of errors. The other thing is that the behavior is disabled by default. Again, this is for backward compatibility and to minimize user disruption. So basically, the clients can migrate at their own pace. However, we actually strongly recommend migrating, and for that reason, we are also logging a warning in the pull replication log on startup, which basically notifies you of this. So this is an example of how you do the upgrade in a rolling upgrade fashion. So here we have the primary one node. We have a primary setup. We have a primary one node which already runs the latest version, so it has all the changes. And then there is a user-initiated action which results in a batch ref updated event for the patch ref for 101, also 141, and the meta ref. Now, the two other primary nodes are still running the old version of the software, which means the flag is going to be is assumed to be false. So what primary one is going to do is basically the old or existing behavior, right? It's going to send one request for the apply object for the patch ref and one request for the apply object for the meta ref for one of the targets, and it's going to do exactly the same for the other target. Now, let's say we have started the rolling upgrade. So primary 2 has come down, it has been upgraded to latest version of pull replication, which has all the new changes being brought up, and the flag is set to true in the configuration. In this case, for the same message, we will see that primary 1 now knows that primary 2, based on the config, knows that this is actually this supports batching, so it's going to send just one request targeting the batch apply object endpoint, and the payload will include both refs. However, for the primary 3 target, which has not migrated yet, we are going to follow the old behavior, which is targeting the apply object, and we're going to have 2 requests, 1 per ref. Eventually, we will have migrated primary 3 as well. So in that case, as you can imagine, there's going to be just 2 requests, 1 per target for the batch apply object endpoint, and the payload will include all the refs. If for some reason you forgot to set the flag for one of the nodes, or you don't want to run batching on that node, it's still not a problem. For the nodes that batching is enabled, then calls are going to be to the batch apply object endpoint. For the other ones, it's going to be to the old apply object. So basically, the bottom line here is that both can happily coexist together. Last but not least, on failures, using this batch apply object endpoint, we're going to fall back to the apply object if the parent object is missing, or in the batch fetch endpoint, for which I'm going to talk a little bit later. And as I have already demonstrated, if the flag is set to false, then we will fall back to the old behavior for that particular replication target, which means obviously calling the apply object with 1 request per reference. And if anything fails, we'll fall back to the fetch endpoint, which is the existing behavior of pull replication. On the second part focuses on the fetch API. The approach is quite similar to the batch apply object. So we have a new endpoint here called batch fetch. And as you can see in this pull replication log, we're targeting the batch fetch REST API. And we can see in the payload, it includes a list of all the refs. This is on the sender side. Now, on the recipient side, things are still work in progress. So the first iteration of the code that we have already merged into master, this cannot guarantee that all the refs from a batch ref updated event will be in a single task. And this is for async refs. If people don't know, if for the fetch endpoint, there is a configuration that allows users to dictate for which refs we want the calls to be scheduled in a synchronous way or in an async way. And the async calls, they have a scheduling delay, which I think is configurable. And the reason being that for optimization, right, you want to get as many into that window, as many refs as possible, so you minimize the number of requests that you send on the other side. Obviously, for sync refs, there is still going to be like one request per reference. So this is basically on the recipient side, we haven't yet touched the existing behavior. However, we are working on scheduling a single fetch task for all the refs in the batch for either async refs or sync refs. Now, the batch apply object endpoint is going to be used when we have large payloads on the batch apply object. And if we fail also we're gonna fall back to the batch fetch when we fail the batch apply object calls. Here, the important thing is that if a ref within this batch apply object call fails, then we essentially fail the entire batch and we try them, through the batch fetch one by one. If the batch fetch call fails, then we have essentially failed replication task. This is how the config will look like in the new world. So we have two remote targets, replica 1 and replica 2. And the new thing here is the enable batch refs setting, which is set to true to enable this. Okay, so before I move into the demo, I need to tell you a few things about it. The first one is, as I said, it's pre-recorded. It's based on tests that I executed locally. So on my setup, I had 3 Gerrit nodes running as Docker containers in a primary replica setup. And I used the Gatling test suite that GerritHub uses. And I ran the test against the Gatling test repo that I created on my primary node. This created about 1,300 changes. And essentially that's simulating sort of a production repo. The test scenario, I'm going to show you 5 short clips, but the test scenario is always the same. So we're essentially demoing 5 different use cases, but the test scenario is always the same here. We have 2 changes that share a parent-child relationship, and we submit those together. So what this will do is it's going to create an event, which essentially this updates 3 refs, right? The master ref where the changes were done, and the 2 meta refs. And we want to measure here how long the replication took. Obviously, there is one caveat here. Because I ran this test locally, my network latency was extremely low. In a production environment, this is going to be quite different, and it could be significant as well. What I have here is on the upper part of the screen, on this terminal, I have the logs from the pull replication logs from the primary node. On the middle terminal, I have the pull replication logs for the replica, where this is relevant. And here I have the UI where I trigger the changes. All right, so let's play this. So we see here we have 2 changes, 1361 and 1381, which basically they share a parent-child relationship and they are merged, they're submitted together. So If we look at the logs, this is running this is with the existing behavior, right? So we expect to see 3 different calls. The first one is for ref sketch master, and this is on the apply object endpoint. That took 13.3 millis. The second call is for the metaref for change 1361, which took 22 millis. And the last change is for 1381 metaref, which took 25 millis. So in total, this is roughly 60 millis. And we see 3 different calls. So here we're gonna see the same test, but with our changes applied. So essentially, here we are, we're gonna be seeing the batch apply object endpoint in action. And again, we have 2 changes, 1343 and 1323. Again, they share a parent-child relationship and they are submitted together. And as we see in the logs, first of all, we see that we received the batch ref updated event, which includes the 3 refs, the master ref and the 2 meta refs for the 2 changes. And we see we have 1 call, which is we see in the payload that we have the master ref with the revision data, and then we have the 1323 meta ref with its revision data, and we have the 1343 meta ref with its revision data, and overall that took 45 millis. So it's roughly 25% improvement here. The third clip, it's on the fetch API. Again, this is the existing behavior. Same scenario, 2 changes, they share a parent-child relationship, and we submit them together. And we expect 3 calls here again, 1 for master, which we see took 200 millis. And then 1 for the 1401 meta, which took close to 400 millis. And another one for 1421 meta, which took 372 millis. So this is roughly 950, 960 millis, roughly, close to a second. And obviously we have like 3 different calls. The next clip is with our changes. But remember that what we have in master at the moment is only on the recipient side. So here we expect, on the sender side, sorry. We expect on the sender side to be seeing 1 request to the batch fetch endpoint, which we see in here. And we see that we have in the payload, we have the 3 different reps, the master and the 2 meta reps. However, on the replica, we see that first we scheduled this 25 E4 task, which was for the 1 meta ref for 1 change, and we also scheduled another one for the 1462 meta, and there's one above for master, which is not shown here. So, if we look at the time that this took in total, we have a small improvement, not much, maybe 6-8%, not a lot. The last one, though, is with our work in progress changes, which is basically scheduling on the recipient side, scheduling a single fetch call. Right, so we have the same test in here, and on the recipient side, on the sender side, obviously we're going to have just 1 call as we had earlier, but the difference here is on the recipient side, so on the replica. We see that we scheduled this CA25 task, this git fetch task, and we see that the payload contains all 3 refs. And if we look at the sender, we see that this took 522 millis, so basically half a second, which is 45% improvement compared to existing behavior. Okay. So the key takeaways here, the key observations that we've had. First of all, we expect at least 50% reduction in the number of HTTP calls that we do for batch refs, because obviously we'll do one call for the entire batch. Another benefit is because we're doing less calls, we're using less threads from the HTTP connection pool, so we are releasing more resources faster to Gerrit as well. From the test that we have run locally, we have observed latency improvement between 5 and 25% for the batch apply object. Obviously, in a production environment, I think this is going to be slightly higher. We've had some improvement in the overall latency of the batch fetch, but not by much. However, once we merge all the changes, as we saw, we expect roughly 50% latency reduction. And this is going to be the big win here. What else? So next steps. We're going to be working to finish the changes that we have in progress at the moment. And we expect this is going to be done sometime in October. Then we will deploy the changes in Gerrit Hub, run the load tests and validate them, fix any bugs that may come up. And once we're happy, we're going to make an announcement and open a bottle of champagne. Thank you very much for listening to us. We're going to open up to questions. Thank you.
Yeah, it's a good question. So we're going to look into the different events which also have this batch functionality. But for now, we are focusing on batch updates. So basically, all the updates which are creating a batch, which are done by batch update in Gerrit, are gonna be sent through as a batch ref updated. So this means that if the patch set is created or updated as a batch update, it's also gonna be emitted via stream events with this new event. Yes, at the moment it should work also for the batch ref update, which contains multiple projects. 2.16 is end of life for some time now, so we didn't thought about backporting that to 2.16. It's gonna be available probably from 3.9. Yeah, it's on our pipeline, so we're gonna have a look into the standard Gerrit integration with CIs, and yeah, we're gonna try to upgrade those plugins as well. All right, thank you very much.